And then for the rest of this practical, we'll run through some non-parametric equivalent tests for when you've got data that's not suitable for parametric tests. The first one we'll cover is the Mann-Whitney U test, which is an equivalent for an independent t-test. When you've got two groups and they're independent, but you can't use a t-test, then this is when you'd want to use a Mann-Whitney U test. We'll run through an example of this. This research scenario, a doctor wanted to see whether a new type of medication for depression would improve symptoms among the patients. So she split the patients into two groups. The first group continued with existing medication, while the second group took a new type of medication. And the doctor wanted to see whether the new medication would reduce symptoms of depression. To determine this, after a 3-week period, she got her patients to rate on a scale of 1 to 5 whether symptoms had got much worse, slightly worse, whether there was no change, whether they'd got slightly better, or whether they got much better. We've got an independent samples design then, one independent variable with two conditions, existing medication or new medication, one dependent variable, but this time we've got a dependent measure which is both ordinal, it's measured on an ordinal scale, it's a rating scale from 1 to 5. So technically we really can't be certain that the intervals between the levels in the scale are the same. So really we should treat this as ordinal data. Additionally, we've got a combination of both non-normally distributed data plus a small sample size. And it's this combination which is especially problematic for parametric tests. If you've got a large sample size, then you really don't need to worry too much about non-normal distributions. But quite often we are dealing with fairly small sample sizes. So this time we'll use a Mann-Whitney U test for this data. And just to illustrate that, what's happened with this data, these are the frequency distributions for the existing treatment on the left and the new treatment on the right. And you can see that what's happened is the new treatment seems to be having an effect in that the symptoms have improved with this new treatment. But what that's done is it's led to a skewed distribution for this group. So when we've got this in combination with a fairly small sample of 15 cases per group, this is why we'd want to use the Mann-Whitney U test for this data. Right, in SPSS then, I've got this data set up so that we've got groups. Code of 1 is existing treatment and code of 2 is new treatment. And symptoms on the rating scale from 1 to 5, which in the data view looks like this. So we'll run the Mann-Whitney test on this now. And what you want to do for these options is go to Analyze and then go to Non-Parametric Tests. And you'll see that the output that you get for non-parametric tests is quite different to what we've been using so far. I think SPSS decided to fiddle around with our output for these tests for some reason, and then maybe abandoned the concept. So we'll go through some of these non-parametric tests now then, and you'll see you can actually, from this option, use non-parametric tests for both independent and related samples. And also, if you've got more than two groups, you can use these options as well. So it's fairly flexible in terms of what you can do with these tests. We'll run through the Mann-Whitney test first. What we need is an independent samples design, which brings up this box. And by default, this automatically compare distributions across groups is selected, which will keep, you'll see in the description, it will calculate a Mann-Whitney U test for two samples here. And what you'll see is for these variables now, group and symptoms, groups classed as a nominal variable because it's in groups. Symptoms is classed as a scale variable because for some reason, if you specify that as an ordinal variable, it doesn't like to, or at least for my SPSS, doesn't seem to like to run the test. So I've just left it at scale, but just bear in mind that this is technically ordinal data. We'll put group down into this groups box here, and symptoms across into the test fields box. So this corresponds to independent variable and dependent variable. Now, if you press run, then it will bring up the output. I'll just slide that over a little bit. Mine's taking a long time to run. It'll get there eventually. There we go. Now what you'll see is, as I said, the output's very different. You get, first of all, this box, which just summarizes the p-value and tells you whether to reject or accept the null hypothesis. We want more from the test than this, so what we need to do is double-click on this box. This now brings up the following output, and you can see now it's reported the full test statistics that we need. And you can see from the graph here, the way that a non-parametric test such as the Mann-Whitney U Test works is that it ranks the data rather than just looking at the scores themselves. So this has ranked the data, and what it's done is it's given us the test statistics, which are, first of all, total sample size, gives us here, the Mann-Whitney U statistic, which is here. Now, this is the one you'd want to report, but quite often you'll also see the standardized test statistic being reported as well. And this is a Z-score, so it's quite a handy, interpretable type of statistic to report, because you know that if it's above plus or minus 1.96, then this p-value that we get out of the test is going to be significant. We'll have a look at the significance now, and if you go down to exact significance, the p-value here is 0.026. So this is a significant difference between the two groups. What we'd want to do is have a look at the median scores to see which group is scoring highest and lowest. So what we'll do is go back now into the Analyze and Descriptive Statistics, and we'll select Explore, which will bring up this table, and we'll split the group, if you like, by group, and have a look at symptoms in the dependent box. Then click on OK, and then what you'll find is you'll get the descriptives out, and this will give you the median scores for each of the groups. So for the existing treatment, the median score was 3 on the rating scale, and for the new treatment, the median score was 4. So this suggests that the new treatment was more effective in reducing symptoms than the existing treatment. What you'll find is when you've got a rating, where you've got a scale which is based on very few points, the median scores might not look very different, but the Mann-Whitney U told us that this is significant. So the new treatment is having a significantly better effect than the existing treatment. And for this data, that's really all we need to do, because we don't need to look at any post hoc tests. We've only got 2 groups. So that tells us everything that we need to know about this data. What we'll do next is go on to a design when we've got more than 2 conditions. So then you need to look at the post hoc tests as well. And we'll do that in the next section of the practical.